Hello guys, my name is Neha Bhoir and from today onwards we are going to cover the syllabus of Medicinal Chemistry 3 Sem 7. So this is our very first unit, that is antibiotics. So in this video we are going to study thoroughly on lactam antibiotics, their historical background, their chemical degradation, lactam antibiotics classifications, and mainly about the penicillin. So let us start about antibiotics. So what exactly antibiotic is? So we have written that origin in the word itself say that is against life. Anti means against, bio means life. And antibiotics are specifically a drug that kills or inhibits the growth of bacteria. They can either be bactericidal or bacteriostatic. Bactericidal means that they can kill a bacteria. Whether bacteriostatic is they can stop the growth. Okay. Basically, antibiotics are chemical substances, okay, that are obtained from various species of microorganisms itself, like bacteria and fungi, that suppress the growth of other microorganisms. Eventually, they may destroy them. Okay, so they made it possible to cure the disease caused by bacteria. Here it's the classification of antibiotics. This classification is thoroughly based on the chemical structures. Okay, so beta-lactam antibiotics are further divided into penicillins, cephalosporins, monobactams, and beta-lactamase inhibitors. Okay, so here we have to learn about penicillin, cephalosporin, and monobactams. Remember that beta-lactamase inhibitor is a drug which is given along with beta-lactam because bacteria obtain resistance to beta-lactam by producing beta-lactamase enzyme which attacks the lactam ring. So, for the prevention of that, we give beta-lactamase inhibitors with penicillins, cephalosporins, and monobactams. This is just an overview. I'll explain you further about the same. Characteristics must an antibiotic possess. It should have wide spectrum, eliminated completely from the body, should not produce adverse and side effects. It should be highly effective in low concentrations, non-allergic to host, chemically stable, and should have a long shelf life. Here we can see that when a beta-lactam ring is attached to other rings such as maybe thiazolidine or dihydrothiosin, how it gets converted to other spectrums. So we can clearly see the beta-lactam ring in the video. When it is get attached to a thiazolidine ring, it becomes penicillins. You can clearly see the thiazolidine ring and the beta-lactam ring. Further, the same beta-lactam ring is get attached to a 6-member dihydrothiosin and it becomes a cephalosporin. Further, when this beta-lactam ring plus 5-member ring get attached, but the carbocyclic 5-membered ring, it becomes carbapenems. Further, the beta-lactam ring when get attached to a sulfo group, a side sulfo group, it becomes a monobactam. So this may be clear that how beta-lactam ring gets converted into other spectrums when get attached to different rings or member. So we're further going to discuss about penicillin, which is mentioned in our syllabus. So penicillin was derived from Penicillium fungi discovered by Alexander Fleming in 1928 on an accident purpose. Okay, so what happened is that Fleming accidentally left a Staphylococcus bacteria uncovered for a few days. So when he returned to find the dish, he saw the dotted dish with bacterial growth, but apart from one area where the patch of mold was growing, thereby which he discovered an active substance called penicillin. This was the whole story and the scenario. Now in the video we can clearly see the beta-lactam ring, a carboxylic acid side chain, a thiazolidine ring, and acyloamino side chain, which makes a penicillin structure. What is the mechanism of action of penicillin? So it is bactericidal, that it works by killing the bacteria. How it works? So basically it binds to an penicillin binding protein, which further blocks the transpeptidase enzyme, okay, which is required for cell wall synthesis of bacteria. Now let me explain you how transpeptidase enzyme work. Okay, so transpeptidase enzyme is required by the bacteria for its growth. Okay, and we have to stop that growth, so we are blocking the enzyme which is required for cell wall synthesis of that bacteria. So if we block that transpeptidase, no cell wall growth will occur and the bacteria will die from cell lysis. Okay, penicillins do not kill other cells in the body rather than the bacteria. This was the whole mechanism of action. Okay, so I have basically studied the blueprint and syllabus of SEM 6. So when we see or when we talk about an exam point of view, these are the only structures you have to be focused. So this is the R group. When we attach this group over here, it becomes penicillin G. These are the R groups and these are the drug name. So when these R groups get attached over here, it becomes this. Is it clear? We'll be starting with structural activity relationship of penicillin. Okay, so what we have studied, that this is the beta lactam ring, this is the thiazolidine ring, a carbocyclic group, methyl groups, and acyl group, acyl amine group. Okay, so when we start, we have to start numbering from S, that is 1 2 3 4 5 6 7. So basically these are the 7 positions. So on position number 1, when the sulfur atom of thiazolidine ring is oxidized to sulfone or sulfoxide, it improves acid stability but decreases the activity of the agent. Okay, means here if a sulfone or sulfoxide group is added, it improves the acid stability but the activity will eventually decrease. On number 2, no substitution is allowed, that any change will lower activity, means methyl groups are an essential part to possess or show an antibiotic activity. On position number 3, when a carboxylic group is replaced by any other group, the activity decreases. Means a carboxylate acid is required to show the position or activity of antibiotic. On position number 4, nitrogen atom is must. You can see here on position number 4, there is a nitrogen atom. On position number 5, no substitution allowed, otherwise activity decreases. On position number 6, substitutions are allowed on side chain. You can see that on position number 6, an acylo amino group is added for better activity. Further, the electron withdrawing group increases activity and gives better stability, decreases activity. Here we can see a carbonyl group. Other substitutions may decrease the activity. Okay, and also on position number 6, a bulky group is added close to the ring, will make the compound more resistant to beta-lactamase. Steric hindrance provide protection to beta-lactams. So we have seen that on position number 6, numerous groups are being added over here so that the structural activity changes, like penicillin G, penicillin V. When bulky groups are attached over here, it gives resistance to beta lactamase enzyme, okay, which attacks the beta lactam ring. If we are getting a resistance, so it is a kind of protection to the ring or protection to the drug. Understood? Now on position number 7, a carbonyl group is must. Other substitution decreases activity. Here you can say that on position number 7, there is a carbonyl group which is must. Other substitutions, any other rather than carbonyl, whether it's ester, any other, will be decreasing this activity. Now you can take the screenshots if you need this. Okay, so this was all about SAR of penicillin. Remember, we have studied thoroughly upon penicillin structure, its SAR. There's This is like a favorite part of ours, that is adverse effects and therapeutic uses. I'm not going to read that. You can take a screenshot of adverse effects as well as therapeutic uses. Come to chemical degradation. What happens when penicillin gets reacted with other components or reagents? Okay, so here you can say that when it is penicillin being reacted with amidase, it will form 6-APA. When it is get reacted with CH3OH, it forms penicilloic acid, same as that, but reagent changes, that is alkaline pH, NaOH. And when it's get reacted on basis of acidic pH, it forms penicillic acid. You just have to remember this structures and their names. This was all about penicillin. Thank you so much. Okay, guys, so in this lecture we have studied about lactam antibiotics specifically for penicillin. So in the next lecture we'll be covering with cephalosporins, lactamase inhibitors, monobactams. Okay, so stay tuned for the next video and let me know in the comment sections, do you want any other syllables rather than medicinal chemistry? And subscribe my channel for more activities. Press the bell icon. Thank you.